Alright, for 715 we were looking for the time constants for the RL circuit. So this was strictly just an exercise of equating resistance to the inductor. We could have easily flipped this out with a capacitor, just use the different formula for basically the resistive capacitive circuit, which would be RC. Now remember that R over L or RC has everything to do with the root of the characteristic equation. But let's take a look here at these two examples here, basically for finding R Thevenin. Now remember, like to keep it straight in your head of where we're equating resistance, everything that we're looking for are responses to the capacitor or responses to the inductor. So this is where we really want to make sure that we're looking at the resistor that the capacitor, or in this case the inductor, actually sees. So for the first one here, we had basically 10 ohms, 40, and 2. And then we had this 5 Henry inductor here. So we wanted to equate all that resistance to that 5 Henry inductor. So that means we would actually combine 10 and 40 in parallel. And that combination in parallel gave us 8 ohms. And that combination therefore became in series with the 2 ohm resistor. So personifying ourselves as that 5 Henry inductor, we're just looking right into the circuit and taking 8 ohms and 2 ohms as the resistance that we see as the inductor. Sure enough, Ta L over R Thevenin, that's 5 over 10 ohms. Bam, 0.5 seconds. Piece of cake. Now, this one may be a little bit harder to actually look at, but it's a great exercise in seeing what type of resistance would be seen by that inductor. So here we got 40, 48, and then 160 ohms, and then we got this 20 millihenry inductor right here. Now remember, millihenry, that's 10 to the negative third. So 40 in parallel with 160, that gives us 32 ohms. But that parallel relationship here, sharing those two nodes, collapses basically an orientation here in which we actually have 48 becoming in series with that equivalence of 32 ohms. And so sure enough, what we see right here, guys, is we get 20 millihenries over 32 plus 48 comes out to be 0.0003 seconds, or 300 microseconds. So, anyway, all right, on to the next one.